Hello and welcome. In this presentation, we will be looking at calculating volume. So, at the end of this lesson, hopefully you'll have a better understanding of how to calculate the volume of a prism. Now, what is volume? Simply put, it's the amount of three-dimensional space an object occupies. So, in other words, how many cubes, a cube is a three-dimensional space, can I put into an object? How many cubes fit into there? That is volume. Now, the units of volume, typically we would start working with meters cubed. And that can be broken down into kilometers cubed, centimeters cubed, or millimeters cubed. Now, to convert from a kilometer cubed to a meter cubed, we multiply by 1000 cubed, or if you prefer, 1 billion. So that's 1 with 9 zeros afterwards. Likewise, you can do a conversion from meters cubed to centimeters cubed, multiplying by 100 cubed, and so on and so forth. Also, we are working with capacity. Well, what is capacity? That is the amount that something can hold. You think of volume as how much space something takes. Capacity, on the flip side, is how much something can hold. Typically, we work with the base unit of litre. And a litre can be converted to kilolitres, which is 1,000 litres, or megalitres, which is 1,000,000 litres. Or, if you need to go the other way, millilitres, which is a 1,000th of a litre. And these are the scaling factors that you need to multiply by. Now, what is the relationship between volume and capacity? Well, a relationship, well, perhaps not that sort of relationship. 1 millilitre equals a centimetre cubed. That's the key relationship. If you need to convert between centimetres cubed and millilitres, there you have it. 1 litre equals 1,000 millilitres or 1,000 centimetres cubed. That is a fairly common one that is used. Or a kilolitre or 1,000 litres equals a metre cubed. Now, again, working with the area of standard shapes, an understanding of this is essential for working out volume. I'll just flip through these. I've gone through these a couple of times. Area of a square, area of a rectangle, area of a triangle, area of a parallelogram, area of a trapezium, area of a circle, sector, and kite. Now, just a reminder, what is a prism? Now, a prism is a three-dimensional object that has uniform cross-section in the shape of a polygon. So you'll see here with the triangular prism, it has a uniform cross-section which is a triangle, because if I cut this here, I will still see a triangle. Cut the pentagon along here, the face will still be that of a pentagon. Now, how do I go about, well, what is the strategy for calculating the volume of a prism? What I need to do, look at my prism. Look for where there is a consistent cross-section area. Then I need to multiply this area, in other words, that cross-section, see the red one there? That area, multiply that by its height. So I need to multiply this area by its height. So volume equals the area multiplied by the height. And that's the only formula you really need to know to calculate volume. So let's have a look at a couple of examples. So, first example, well, again, volume equals the area of the base times the height. So where is the cross-sectional area? It's along here. It's this triangle here, because when I cut this prism along here, I still will have a triangle as the cross-sectional area. So what I need to do, calculate the area of the triangle, that's that area there, and multiply by the height. Put some numbers in, a half area of my triangle, 4 times 5.4, and multiply by 6, which is the height along there. That will give you the volume of this particular triangular prism. Let's look at the next one. Again, if I cut this along here, I will maintain a rectangular prism. So what I need to do, calculate the area of the base there. That's my base, this area here, and multiply by the height. So area of this base is 2 multiplied by 4, and I need to multiply that by 6, which is the height of my prism. So there you have it. And I think we have one more example. Okay. Again, the cylinder. Notice it has uniform cross-sectional area all the way through. So I need to calculate the area here, the area of the base of my cylinder, and multiply by the height. What shape is this here? That is a circle. So area of the circle is pi r squared, multiplied by the height of the cylinder. All I need to do now is substitute the numbers into the equation. Pi times 2 squared times 4. Well, there you have it. That is the volume of my cylinder. Okay, last example. Say I have a prism. And it's a glass prism, and it has a volume of 400 centimeters cubed. And I wish to calculate the height of that prism, and I've been told the cross-sectional area, this area here, is 40 centimeters squared. How would I go about doing that? Well, I would go back to the original equation. Volume of a prism equals the area of the base multiplied by the height. Now, I am looking to calculate the height. So I could rearrange this formula to say that the height equals the volume divided by the area. All I have done is divided this side by A, which gets rid of that side, that A, and this side by A. So you have been told the volume is 400 centimeters cubed in the question, and you have been told that the cross-sectional area is 40 centimeters squared. So substituting the values in, height equals 400 divided by 40, or equals 10 centimeters squared. So to summarize, for each particular question, go back to the original formula. The volume of any prism is the area of the base, this area here, multiplied by the height. Calculate the area of the base, and then just multiply it by the height, and that will give you the volume. So you see, that's what I've done in this question with a cylinder. It's what I've done in this example with a rectangular based prism, and this one here with a triangular based prism. So until next time, good maths. Bye for now.